All right, great. All right, actually, maybe I'll pause it. You guys need to turn your deck. All right, here we go. We're back. Yep. All right, we're talking about the law of cosines. Y'all just did an activity to prove it. Those at home want to practice proving it, you can go on to Edmodo. It's on there as well, along with the video, because we didn't quite have time and to get through this and have a little time for classroom. So this is how I'm running it today. The law of cosines, after we derive it, we have the sides. These are the sides. They're the baby A, baby B, baby C. We have some more of it here, A and B, more sides, and then the cosine of C. So it doesn't matter what the triangle's labeled. It could be D, E, F. It could be M and O. It doesn't matter. What you really need to focus on, and this is my hint, if you're looking for an angle or you have information on the angle, that's your angle C. Okay. The side across from it is your baby C. A and B, it doesn't matter which is which, because look what we're doing with them. We're going to square them and add them. It doesn't matter which comes first there. Commutative property, doesn't matter. Same here. -2 times A times B. Those are all multiplied together. 2 times 3 times 4, same thing as 4 times 2 times 3. Okay, so really all we need to point or find here is what is my angle and what is the opposite side. Those go in those positions. It's a triangle, so the other stuff has to fit, right? Okay. So you need, in order to use this, you need 3 of the following. There's always 3 sides, but that's not quite, yeah, actually, that would be enough. 3 sides, or you can have 2 sides and the angle that corresponds. Okay. So, honestly, I feel like the main thing to notice is what is the angle I'm looking for or have, and what's the side across from it. It's very basic how to put it. Okay. But we have to do some practice because a lot of folks are having trouble with just like the calculator work. It doesn't seem like it's that hard, but this context, this syntax is kind of hard to get into a calculator, especially if you're the person that likes to put it all in and then just put execute. Yes?
Wait, can we still do it if there was 2 angles on one side?
If I had 2 angles on one side, I'd use the law of sines to find the other side, and then use actually 2 angles on one side. You could do a lot with that because you know the third angle because they all add up to 180 or 2 pi. So what you're suggesting is like, you know this. You know this is 60 and this is that. But you know 2 sides. Maybe this is 10. You know 3 angles or 2 angles? Well, here we know that now. That's not this one. So with this, I can then find my other sides using the law of sines or cosines. So what you just brought up is like a specific situation that doesn't quite apply to this.
Yeah.
We could probably get this through the law of sines, get everything. Question, Gene?
How does 180 equal 2 pi? I thought it was equal to pi.
Oh, did I say 2 pi?
Yeah.
I'm sorry. It's pi. That looks sick. That's like a sick mistake. That mistake is sick. All right. So, angles, sides, all included here. Find C, round to the nearest tenth. So let's first just look at the problem. Do we have information about a side? Or excuse me, an angle?
Yes.
Okay. The one angle, this tells me that angle C, angle C is our angle we're looking at, and the side across from it happens to also, you know, we know in this case it actually is going to fit really nice in the equation. So look what we have. We know the angle, we know the side we're looking for, and even if we weren't looking for C, if we knew this value for C and we were looking for, you know, side A, baby A, you would still notice this is the reference angle, so that goes, the cosine is applied to the reference, not reference angle, of the theta that's given. And the side that corresponds, it goes out here and everything's equal to that side. Okay. So the key thing is look for the angle you're looking for. Keep in mind what you're looking for as far as sides, but because this is the angle we're given, we're going to use that, and I know now that it's going to be C squared, right? It's equal to, now does it matter which is A and B? No. It doesn't matter, because look what we're going to do with it. We're going to square it and add them. Square B and add to A. Square A, add to B, same thing. You multiply -2 times AB or multiply -2 times B times A, same thing. Okay, commutative property. So we're not going to worry about that. I'm just going to throw in 9 squared plus 15 squared. and that's minus 2, 9 times 15. Cosine of 29 degrees. So what mode are we on in our calculator? Degrees. Easy. What is missing? What's the one thing missing here now?
C squared.
C? Yeah. So we get through this. At the end, we'll have to square root it to get the actual C value. But you can see a lot of this is just going to be some calculator work. You have to be really careful. And I'm going to show you the part that's like the crux. Okay, this is the part that's the crux. So C squared is equal to 81, 225, what's that? 270 cosine 29 degrees. Okay. A lot of people are doing this mistake. So everybody look up here and think about a strategy on how you would approach this. I want you to think about your strategy. Just get in your head. It's okay if what I bring up changes your strategy. Just think about it like that. First strategy maybe isn't the way to go. So some people are doing this. 81 plus 225, that's 306. 306 minus 270, that seems like it's right. That's, I get 36. Why isn't that right? Negative 270 times the cosine 29 degrees. So it's a matter of PEMDAS. If I work this out, I know this is going to be 306 minus 270 cosine of 29 degrees. You can't just take this multiple because they're multiplied together. You can't split those up. If you think of PEMDAS, you do multiplication before addition subtraction. So you have to do this part. You have to do this part out first and then combine it with the 306. It doesn't seem like that's where the error would happen, but people are just getting excited. They're like, I want to get rid of all my numbers. Jackson.
I got negative 0.74
For the whole answer?
Oh, never mind.
Well, let's see. Are you saying for the cosine of 29?
I was in radian. I had a question about cosine because it was negative, but I was in radian.
Okay, radian will give you a different answer. So,
yeah.
Degree mode, or degree mode. All right. Somebody help me out with this. What's the cosine of 29 degrees times 270?
Negative 236.
Just let it. Thanks. So I say keep as many digits as you could stand in the problem. Makes it more accurate for your answer. So now we just have to subtract that, and we're going to get, 70.147? Right?
69.8.
Okay. Because it's the other way around. Jackson, help me out. What is it?
69.8526.
That's enough. Thank you, sir. And then we're going to just square root that to get our C value. So we square root that. Jordan, welcome to class. All right. What do we get when we square root that, Jackson? Jordan has most answers, not that one.
Yeah, okay.
8.36.
Oh, it's okay. It says the round to nearest tenth, so 8.4. Good. 8.4 feet. At the end, look to see what you're finding. If you're finding the last side, look to see the units for the other sides. So, how do we feel about applying this? Deriving, I feel like we're all like here, maybe like that. That's going to be a homework item. But how about applying it right here? Pretty good, right? It's kind of like one where after you derive it, good, you get it too. He's seen it. So once you derive it, then applying it is just arithmetic. Just a trick. It's just a trick, okay? What is different between example 1 and example 2? What are the main differences? Yeah, Drake. It doesn't have an angle measure. What are we actually finding? We're going to find? Radians. Put your calculators in radian mode. And also we're finding, we don't have any angles. So this is where, remember, anytime you're looking for an angle, you're going to use what? What are you going to end up using at the last step?
Inverse cosine.
Good. Arc sine, inverse cosine. Same thing. So we're going to use the arc sine. I could say this is aka arc sine. Okay. So just remember, when we're looking for the angle, you know at the very end, instead of taking the sine of your angle, you're going to take the inverse sine of the ratio on the other side. That will give you your angle. It's just the opposite direction.
Yes. Going to be the cosine, or is it just the sine? I'm just confused because we're talking about like cosines.
Correct. Thank you. All right, so that was an error on my part there. When we are looking for the angle, we're always looking at the inverse or the arc of that function. And this is the law of cosines, so it's the inverse cosine or arc cosine. So we're looking for angle L. Here's the deal. Here's the angle I'm looking for, right? What side corresponds with that? I need to link those. So in essence, this is my capital C, even though there's different letters here. That's my C. A and B. At this point, I actually don't mind if you transfer it into ABC. It really won't matter. No, it won't. There's no point where you're going to really come into trouble with that, as long as you remember your key on what you changed here. But we're going to go with 8 squared is equal to A squared. I'll call that B squared minus 2, 6, 5, cosine F. What's the one thing we don't know now?
Angle.
We don't know the angle. So when you're looking for the angle, we're going to definitely use these arcs cosine or inverse cosine. So work that out. I'd say do what you can, mental math. Do what you can mentally. 64, 36, 25, 60. Finish it up. Don't subtract that 6. You got to multiply it, remember? But after we do that, get everything to one side so your unknown is alone. It's isolated. Isolated. Yeah. Okay, 64. 61 minus 60. Oh, see, this is where it's so enticing. You're like, oh, 61 minus 60. I wanted to make it 1. Don't do it. Because PEMDAS, this is multiplication. You got to do that first. So instead, what we're going to end up doing is
Divide.
not quite. Let's get that 61 out of here. So order of operations isn't talking about necessarily. It's talking about how you combine values with operations. If you are trying to isolate what you're looking for, you always work like an onion from the outside in. So I want to get rid of all the parts I can, working my way in. Now, once I do this, I get 3 is equal to negative 60 times cosine of L.
Then you divide.
Everyone okay with how I got there? Yeah? It's okay. No. How do I get to the cosine of L when I have that last thing here? G?
I have a question.
Okay,
But
good.
you just finished up.
No, take
So the very first step, so we have 8 squared equals 6 squared plus 5 squared minus 2. If you just want from there solve for L, would it be right to do L is equal to inverse cosine times 5 squared plus 6 squared minus 2, 5, 6 divided by 8 squared? Or
So basically you're saying before you even get to this, try to get everything else over to the other side.
yeah,
That's a strategy, but
I
that's
just wondering if I did it right.
you could do it correct that way, but it is a clever way and it may not help you with every problem. Do it quicker. So think about that. I say try it. I know that'll work. I can write it out right now if you want. You want to see how it works?
I just want to make sure
Okay, so you would end up with this. You'd end up with 8 squared minus 6 squared minus 5 squared divided by negative 2 times 6 squared times 5 squared. And you could even say from there, all that is inverse cosine, arc cosine, that's going to be equal to angle L. Sure. I don't want anybody else to do it this way. That's just a creative derivative idea, you know, not a derivative. It's a path you can take. Let's finish in the regular path of least resistance. It's always good to know both. Know a complicated way and easiest. All right, I want to test your mental math. First off, what does this reduce to? 1 over negative 1/20th. Negative 1/20th. So I think of any time I get into 1/20th, there is a certain money piece that I think about. 1/20th, what is that going to be? Nickel. Nickel. Okay? 5 cents. If you break 100 cents into 20 parts, you get 5 cents each. So what should I put here as far as reducing this right here? Negative what? How much is a nickel?
Negative 0.05.
Not 50 cents. 5 cents, right? You see that mental math, how I kind of figured that? This reduces to 1 over negative 20. So 1 divided by 20 is, I think of $1 divided into 20 pieces. That's 5 cents each. Okay. If that doesn't work, forget I said it. All right, Gene, we're at the last step here. What should we use?
Arc cosine.
It's your favorite. I thought you. When I write arc cosine, it's the same as cosine with the -1, the inverse. It's just another name. What's the other one? There's 2 names for it. All right, so go ahead and do the arc cosine. That's the cosine -1. The cosine -1 here. Find that on your calculator. Negative 0.05. That's our. Oh, we need it in radians. Make sure you're in radian mode. It's really only at this point that the radian mode will come into play. But what do we have there?
1.6208.
0.8. I think they didn't tell us, so I'm going to keep it there.
All right.
Radian. Okay. So in this one, we had to use the arc cosine because we were looking for the angle. Over here, we used the cosine midway just to get our value. I hope that's starting to click on which way uses which function. Thumbs up, sideways down for this. Give me some votes. Okay. I want you to work in partners for this. Some of the problems you'll need to work together on. So just have someone handy that you're friends with. Not mortal enemies, no nemesis. Nemesis? 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 It's not US, is it? It's IS, nemesis. We have to know. So it's SIS, it ends SIS. But the plural is, for those at home, this is very important for you too. Oh. What you're saying is the plural is ES. Fantastic. I thought you were spelling nemesis. No. Nemesis. The I changes to E. Nemesis. Good job. I didn't know that. All right. Thank you for watching. Goodbye.